All right, this video is talking about conditional probability within our first section. And conditional probability of A is, or I guess first of all, conditional probability means we're going to be looking at a smaller subset of our total sample space. And so it's the probability of an event happening given another event happens. So probability of A given B, and we write that as probability of A with this vertical line B. And that stands for the probability of A given B. So we're looking at just the part where, just the sample space where B occurs, and then we want to find the probability that A occurs inside of that smaller sample space. So you can think about this as reducing the sample space. I think it will help make some sense to you. So the probability of A given B is the probability that event A will occur given that event B has already occurred. So once event B happens, then we need to find event A happening on top of it. So it's kind of calculating two probabilities. A conditional reduces the sample space, as we talked about. And so we calculate it with this following formula. I'll start with what's on the bottom. We calculate the probability of B happening first, and that we put that on the bottom because this is the probability of A given B. So we need B to for sure happen because it says given B. And so instead of looking at our full sample space, like for rolling a six-sided die, instead of looking at 1, 2, 3, 4, 5, 6, we're looking at just whatever B is. So if it's like all the evens on the next example we'll look at, that probability on the bottom would be 1/2 because 2, 4, 6, those are the evens. There's only 1/2. Half the time you'll get that. Up top, that's the probability of A. But not only do we need A to happen, we also need A to happen with B, because remember, we need B to be given. So that's why up top it's probability of A and B. So we take these two probabilities and we divide them. And probabilities are almost always fractions, so it ends up being a fraction divided by a fraction. And we'll work on that in a little bit. Let's look through a concrete example here. And let's see, my face is in the way. I'll close that. Okay. So for example, suppose we toss one fair six-sided die. The sample space is obviously 1, 2, 3, 4, 5, 6. Let A be a 2 or a 3. And let B be an even number. So 2, 4, 6. To calculate the probability of A given B, what we're going to do is count the number of outcomes, 2 or 3. So that's from A, 2 or 3, inside of our smaller sample space of B, which is 2, 4, 6. So we look and ask, which of these are 2 or 3? Well, only one of them is. Only 1 out of 3 of them is. And that's what gives us our answer of 1/3. So it's a way to do it without using the formula, but oftentimes it's easier to use the formula. So probability of A given B. So we identified A and B. And here we're going to write out our formula. On the bottom, we'll always start there. The probability of B, that's our given. So B was the face is even, 2, 4, 6. So to calculate the probability of even 2, 4, or 6, we put all of the numbers that are even over 6. So 3 out of 6, because there's 3 ways to do it, out of 6 total. And up top, we want to calculate the probability of A and B occurring. So the only way for A and B to occur, A is 2 or 3, and B is evens, 2, 4, 6. The only way for A and B to occur is one result, a 2, right? Because a 3 is not even. So there's only one way to do it out of 6. So that's 1 out of 6. So now we have 1 out of 6 over 3 out of 6. And what we would do is multiply, we could type that into our calculator, or we can multiply by the flip of this fraction on the bottom, 6/3 and 6/3, and you find out that you end up with 1/3. Or another way to think about it, 1/6 divided by 3/6. You can see here, these are each in terms of sixes, or sixths, I should say. And this is one of them, this is 3 of them, so 1/3 it would simplify to. Our next page is going to be working out some example problems. And I think I might make another video for this one, actually.